Morning here everyone. In my last video we saw this WM8960 eval board that I have here. So this was the WM8960 audio codec that I have here, and with respect to that we saw how I had fixed the driver related to WM8960. So the driver was having some issues with respect to the kernel which I had again built for my Rpi4 board actually, that we can see here, the Rpi4 board. So I had basically built the driver for 5.4.75 kernel version, and for that kernel I had built the driver for this WM8960 audio codec, and there were some issues related to that and I fixed it. So now in this video I would be demonstrating a small application around this board, the eval board I have here. So along with WM8960 audio codec, the board also has two microphones actually. So we can see here, so this is one microphone that I can see here, and this is the other microphone. So these are the two analog microphones. So these are basically two analog microphones and not digital microphones. So there's a little difference between these two actually. Like in case of digital microphones, you have an ADC. The ADC comes into picture in case of digital microphones. So what happens is that the microphone is analog only, but then there is a ADC present on the microphone module, which does the conversion from analog to digital, and so you get the digital output actually. So, but in this case, what we have here is our analog microphones here. The two are analog microphones, and so these two analog microphones are connected to the WM8960. So there are two analog signals, the left and the right microphone that you can see here. Left input, the right input, and they are going to the left in and the right in of this chip WM8960. So if you see the schematic, it would be something like that, and so they are coming to the WM8960. The inputs are coming, and these microphone inputs are being converted from analog to digital using the ADC, which is present in WM8960. So the WM8960 audio codec has an internal ADC which does the conversion actually from analog to digital conversion, and after that does the processing and all the audio part that comes in picture actually. The noise reduction and the DSP and microphone calibration and ADC gains and all the settings actually that we have done with respect to the registers of the WM8960 driver. So there are a lot of microphone settings are there with respect to WM8960 also. So if you see the data sheet or the driver of WM8960, there are a lot of microphone settings that we need to do actually, so as to process this microphone signal actually, so the gains and all the other things actually. So let's cut back to that. So now in this after this we could do a successful audio playback and speech capture in my last video which we saw. So in this video I would be demonstrating a small application which is a Picovoice demo actually. So first what I will do is that the main feature of this is that it runs offline actually. It runs on the edge actually. So this Picovoice is running on my Rpi4 board. So on my Rpi4 board, the model is basically trained actually to detect the intent, and basically you have something called as intent actually. So what is the intent? The meaning of intent is that with respect to expression that you say actually, so it will try to find out the intent based on the slot and whatever is the expression that we are saying. So it will try to figure out the slot in that and try to associate a value with respect to the intent actually. So that's about it. So basically it does NLP processing here, and that runs on the board actually. So here I will disconnect the net of the board actually. I will disconnect it, turn it off, and so we are completely offline now. And we will run a small demo using Picovoice. So this Picovoice has two parts actually. It has a Wakeword engine, and which detects a keyword or the keyword spotter engine it has. So this engine is basically a Porcupine, is what we are using. A Porcupine is giving this Wakeword engine, and along with it, after that comes to whatever the expression processing. So that part we are doing a speech to intent conversion using Rhino's model, actually Rhino RHN model actually. So I have trained a customized model actually using Rhino. Actually, you can see here Picovoice offers this using Rhino speech to intent conversion. So I have already defined it. I have already trained it using this console that I have given, and I have basically downloaded. There are a few models that you can see here. You can download it using this, and this I have used in my this RPA speaker demo. The sources that you can see here. So if we see the sources. So anyways, I will show you directly actually. So here in Picovoice, this demo is there. So in that, this speaker is there. This I have this Picovoice demo. Yeah, here. So basically, I have handled these intents and processing of the slots and all that, based on which I have processed the actions basically that needs to be performed when the intent is discovered actually, or when we detect it actually. So let's check it out. Let's run it actually. So we can run it using this, and we run, and it starts. Actually, you can see here it starts. It has listed out few slots and the expressions and the values associated with it actually, and it is now in listening mode. So when we say the wake word Jarvis, it lights up, and sorry, detected something, I guess. Jarvis, switch off, so it turns off. Jarvis, turn on the lights. Jarvis, blink the lights. Jarvis, run the lights. Jarvis, purple lights. Jarvis, purple lights. Jarvis, lights purple, so it turns purple. Jarvis, lights red, then it turns red. Jarvis, lights yellow, it turns yellow. Jarvis, lights orange, it turns orange. Jarvis, lights off. So the wake word here is Jarvis actually. So the Porcupine wake word engine provides has already provided with a lot of wake words. Actually, it has already trained and providing a lot of wake words. So I felt like it can be customized. Actually, can we have a customized word? So currently, Porcupine is not offering for these restricted platforms like Raspberry Pi 4 and others, BeagleBone and all that. So that's about it. So the parsing happens on the edge. So it is the edge parsing that is happening here that we should understand here, and it is not related to online parsing and like Alexa or Google, Google or Google Home or something like that. So the processing is happening completely on the board based on the model that has been trained for few key expressions or few expressions that we have here, and based on that only it has limited scope. Yes, I understand it has a limited scope, and based on that limited expression only, it is running that on the edge. That is the board, this Rpi4 board that I have here, along with the WM8960's speech capture. So it is using the WM8960 driver to do the speech capturing part, and taking the speech signal, and that signal is being converted from speech to text, and that based on the text it is trying to apply the model that has been trained for it, and based on that it is providing me the output based on what the processing has happened. So this is the output when the wake word is getting detected and we see some phrase or expression, and this is what we see, and based on that we take the action when the phrases are being detected and the slots present in the intent are provided with some value, and based on that value we do some action. Actually, I hope this is fine, and this completes it all, and thanks for watching. Thank you all.